Hello there, ladies and gentlemen, and welcome to another tutorial on Autodesk Inventor. Today we are going to be looking at constraints in Autodesk Inventor. So normally, the way you create your assembly file is that currently I have one open. You go on top here where we have this new command, click there, and then this window will actually pop up here. So we have already looked at how to create parts in Inventor, the, the standard we have different templates that you can actually use. Although we are yet to look at sheet metal, but I think I'll do a video. It's beyond the scope of this one. We are not going to be talking about that. Our major focus is going to be here on how to create an assembly. Essentially, an assembly is a collection of all those components that you have designed, which are the IPT, and then now you are bringing them to put them together to control the motion on how some of them should move or how they should kind of behave. So we have different templates here. We have the standard we have the weldment here, which we also look at right along mold design and some others. I think the mold design is currently new in Autodesk Inventor 2022. It was never there in 2021. I think it's a new feature that has been added there. Then we have the drawings here, the DWG. You create your drawings after you done your part or your assembly. Then we have the presentation, but those are beyond the scope of these. Yeah, so once you select what you want, like the standard you click create here, but because I have one open, I'm going to cancel out. All right, so before even we continue, I'd like you to subscribe to this YouTube channel, as well as to stick until the end, because I have bonus tricks, yeah, some things that you can never see anywhere other than this channel. So make sure you stick till the end of this. Yeah. All right, so to place your components into your assembly environment, there's this place icon. Click there, and depending on which the root folder or the root directory in which you have stored your files, you can go to that folder and then you open whatever you want to open. So to select multiple, you click on it, and then you click on the first one. You can hold down shift to select like the three of them, or alternatively you can hold control as you left click to select an individual one. Okay, so once you're satisfied, then you click open, and then when you open, this is how it generally looks. This is how they will come into your model. Right now, because you have clicked anywhere, you can actually place them anywhere that you want. If you right click, you can even rotate them. You can rotate X. Yeah, if you right click, you can rotate Z direction and all of those stuff. So depending on how you want to align them for the first time that you're placing them, so it's all up to you. Okay. All right, so then the other thing is that whenever you want, let's say you had one component, you can ground it at the origin, but for this one I don't want to ground anything here, but just to tell you that that option is right there. Okay, so once you bring it, just click anywhere to place them into your canvas. All right, so once you have placed them, I like to change the view a bit to shaded with edges, so that it's kind of clear, so that you see what is happening there. So what I want us to do here is, because these generally when you bring them in, there's no set of rules that governs how the thing should move. Yeah, so generally when you just click and drag around, you can just move it in any direction. Yeah, there's no constraint that has been put to it. Yeah. All right, so the first thing, when you click on the assemble tab here, there's this icon here, the constraint. We have the joint we are going to do. I think we can look at joints next, but because it's when you click constraint, you have other constraints here inside here, like the angular constraint, the tangent, and all the inserts, the symmetrical. So, but for the scope of this one, I just want us to deal with these ones. If you know these ones, even when it comes to talking about joints, then it's just something very easy to understand. All right, so what I want us to do here is that let me delete this because I don't really think it's really that necessary. If we need it, then we are going to bring it back. All right, so one thing I want us to do is that we want this. We have the first of all, I think I did not talk about what we have. We have this is the rack gear, so generally it transmits linear motion, and then we have this gear here. What we want to do here is that we are going to constrain this one such that it can only rotate at its axis here. And then once the rack gear makes contact with the teeth of this, it is going to make it rotate. We don't want to move around like the way it currently moves, so we want to prevent that. Okay, so click on constraint, and then one thing I always like to do here for that or anything that you could be doing is that once you start hovering the cursor, you start seeing a set of these points, those dots, and then they start line, yeah, that central axis line. So click that, because anywhere you hover, as long as the whatever the geometry of your model is circular, that one is going to pop up. All right, click on that circular face inside, and then when you come to your tree here, your browser here, there's this folder here, the origin. Expand that to see the children of this folder. And then here we have the set of planes. You can constrain the planes, but we want that axis, central axis, to be constrained to the x-axis, not really on the x-axis, but you can always look at this triad here at the bottom. If I rotate, we have the x, z, and y direction. Yeah, so but for this one, I want us these to be constrained along the z axis. So we're going to click on z. Once you click there, it's going to move it. Yeah, you can first, so the default is this one. You can flip it around, yeah, all of that depending on what you want to do. So I'm going to leave it by default. Then here you can always offset away from that axis. You can put like 10. If you put 10, it's going to offset down. If you put a negative value like that, is going negative value. So depending, you can do anything, but for this one, I want us to leave it at 0. Click apply. Okay, the expression couldn't be a variable. Let's put 0 there. Okay, then click apply. All right, then once you're done with that, if you try dragging, you can see now it doesn't move along the, it can never move, it's not moving in this. Okay, it's kind of sliding along the z axis like that, so it cannot it can just rotate as well as do what slide in and out. Yeah, right. So the other thing we want to prevent is this sliding action here. Right, for that you click on constraint using the mate constraint again. Select now a face, okay, because now we used an axis, the central axis, but when you hover on this face, you can see it highlights. Yeah, and then select the plane to which, yeah, depending on what you are doing, how it's aligned, it's all up to you. So we want to align it with the XY plane. Before even click apply, you can see a preview here. We have the XY plane. By default, it's the mate constraint. If you click on flash, you can see now they are flashing. Yeah, flashing means that they are kind of, those faces are collinear as well as parallel to one another. Right, click apply. Yeah, so when it comes to collinear and parallel, I think I explained that thing when we were doing the sketching. the sketching, the 2D sketching, we were this that I'm going to link that link to that video so that you can check it out if you are not familiar with the sketching environment. Yeah, all right, I have a full crash course for 1 hour. You can check it out as we go to the in-depth. All right, so once we are done with that, then if you try to drag now, it doesn't slide. Yeah, so it doesn't slide along the z-axis, but it's now free to rotate. That was the intent that we wanted to do here. All right, and then now the other thing is now we want to constrain this such that we get the appropriate motion. Again, click constrain. For this one, we want now the face of this teeth here to flash with the face of that. By default it's the mate, but if you click flash it's going to flip it around, so sometimes it happens. So click flash to get the correct orientation, then click apply. All right, then let's rotate around to see how it looks from the bottom. Now from the bottom here, you can see now things. You click on these and then you drag around so that you get the correct alignment there. Okay. All right, then I want us to look at the other command. We have used normally the mate here, but before when we come to the angular constraint, I want us to look at the tangent constraint. All right, the tangent such that we have the angular, but I want us to look at the tangent first. Click on the tangent, and then tangent, what it does from your mathematics and all of those stuff is that it's going to make a face. If I select this bottom curved surface that is highlighted in red there, and click this curved surface there, it's going to make those two tangents. And I know now it doesn't really look really like tangent, but generally that doesn't. Okay, we have two types. We have the inside tangent like that, and then we have the outside. Yeah, so the outside, it's going to make it with respect to the outside, but for this one, if we click on the inside, you can see it makes those two kind of, you can see this curved surface along that teeth, and then the other one, it makes it tangent with respect to the end point. I think it's with respect to this. Yeah, so that's about the tangent constraint. If you are done with that, you click apply. But for this one, I didn't want that command to do that, so I'm going to undo that. But that was just to show you what the tangent does. And then we have the angular constraint here. Generally we have again three types of meaning. We have the direct angle here, we have these unit and directional angle, and this. So I'm going to use this one, but I'm going to encourage you to explore these others because I want to keep this tutorial as short as possible. Once you select the direct there, you will need to select a face. Okay, so I'm going to use this face of the XZ plane there. Once you select that, and then we are going to expand the tree of the rack here and go to origin and click that. Okay, immediately you can see what happened there. It flips the entire thing downwards. We can go ahead and put an angle, let's say 90. You can see there what it does, it puts an angle there with respect to that flat surface. Yeah, and then you can do 180. I think 180 is what we were looking for. Yeah, like that. Then once you're done, click apply. Okay, and then you can see now when you try to move it, the way it kind of moves, it can only, yeah, it can transition along this path. That is about the angular constraint. All right, so I'm going to delete that. Alternatively, if you don't want to delete, you can just click on it and then right click, then you suppress it. So suppress it is okay. I'm going to talk about also suppressing and all of those stuff. So suppressing, it's like deleting it, but it is still there. Okay. Since we had the tangent, I think that's why it's behaving suppress. Let's take back the and suppress this. Yeah, so when we are talking about the angular constraint here, by default it was we put there 180, whereby it makes the two planes, yeah, lie 180 degrees with respect to each other. The two planes, then all of those stuff. So that was about the angular constraint. I'm going to suppress that because I don't need it for this scope. And then then the other thing, we have the insert, but I'm going to put a component here from the content center. I'm going to place a bolt here into the design environment, so that so click the arrow down, then select place from the content center. The content center is generally a library whereby you have your components like the pipes, the nuts and bolts. So it's a large, you can see there, it's a large, you don't need to model these components from scratch, so you just place them directly from the content center. Yeah, for this one, what we want is generally the to put a nut, not a nut, but a screw. All right, so let me look for something small one. Let me go with a counter. Let me go with some. Then once you select, click OK. Not you click OK, then what is going to do is going to open this folder here where you have all the hexa heads. Yeah, you can select whichever that you want. Once you done, click OK, and then it's going to load a bit. Once you have it, you can just click empty space there. I didn't want to insert it, yeah, and then you can just choose. I'm going to take the shortest one, the M3, with a nominal length of 6. Yeah, an M3, not really, because that's an M4. I'm going to take an M4. The M4, that's a 4mm with a length of 8. Click apply, and then it's going to take some time to load that, but that it should be done within a very short. So generally, whenever you're placing things from the content center, click anywhere in space. Once you're done, click escape out of that. Therefore, we have these. Generally, these are not threads, these are picture that has been decaled in the face there. All right, so, but it's still bigger. But for this one, the size doesn't really matter. What I wanted us to is to get what the insert command does. So click on the insert and select. So insert, select this edge here, and then we are going to select this edge. All right, so it will move it, but it has put it on the side that we really didn't want, so you can flip it around. That is how we want it. Then once you are done, click apply. Right, so we have here, generally the insert command is that it eliminates 2 degrees of freedom, yeah, whereby we don't really need to put 2 constraints like the way we have been doing here. it eliminates the 2 but leaves you with 1 degree of freedom that it can still rotate around. Yeah, so that's about the insert command. And then the other thing, another tip I would like to give you here is that this bolt, as much as we have put an insert constraint here, let me find it. So to find it in the browser, sometimes when you are doing like an assembly of 1000 components, it's very difficult to keep them on track in your browser here. So to find it in your browser, so you just click on it, right click, then there is this option find in browser. So just highlights for you here where it is. Scroll down, expand the tree there, and then we have this insert. Click on that insert, then right click, then you can edit this. Okay, so when it comes to editing this, because here is where we want to eliminate this rotational motion to make it fix. So to do that, there is this here lock rotation. If you check it, tick it, and then click apply. Now if you try to rotate this, it's going to rotate as a unit. Yeah, it's going to rotate with these. Yeah, it doesn't rotate on its own. Right? All right, so away from that, let's look at something here. I'm going to align that. Let's go back to constraint. Then I think we have talked about the insert, the angular, then there's the symmetric here, of which symmetric, you can actually explore into it what it's going to do, but because I think time has really gone, the other thing I like us now is to show you some of the tips, the bonus tips when it comes to these, yeah, to these constraints. All right, now what we have here is if we try to move this, it can still move. Yeah, it moves around, and when it moves, it doesn't transmit that motion to our gear wheel here. So that's what we want to do here, to show you some tricks, some tips. All right, now okay, because this thing can still move along this direction, that's where we want it. We want now to prevent this up and down motion. Yeah, so how do we do that? So what we can do, we can just select constraint, put a made constraint this bottom surface, then we go to our browser here. There are these planes here, that one really, but let's use this one. And then once we use that, what it does is that it puts, so we're going to take it down, we're going to offset it down a little bit. So let's put 10, let's put -10. That is too small. Let's do 20, but in the negative side. 20 is too far, so let's try something like -15, too close, -18. I think that is perfect. Then click apply. Okay, then we are going to rotate a bit, so it's still crashing. You can see there if I try to do that. All right, so it's still crashing there. We are going to edit that. Going to come here, click edit this. Instead of 18, let's do 18.5. all right, that is perfect. So there is some clearance here. That's normally how it should actually be aligned. All right, now it can only move along the y-axis in this direction, which is good. Now what we want now here is that when it moves and makes contact with this gear, it transmits that motion. Okay, so how do we do that? Comment down in the description if you know before before I say how we are going to do that. Okay, so one thing you can do here is there are things known as contact sets. When you come to inspect here, we have the interference analysis and we have the contact solver. Okay, so one thing we are going to do here is we are going to select the components that we want to activate the contact solver. So we select these and these three components, and then click activate contact solver. Okay, so once you have done that, the other thing I always like to do is to select all the components by green window selection, then right click, and when you right click, there is this option here, contact set. Okay, once you do that, there is this icon that pops next to the part that looks like a magnet, such that when the two make contact with one another, so that it will detect an interference has taken place, and therefore it will force the other component to actually. So if I give you a test, if we try that out to see what that actually is. So if I drag this, yeah, you can now start to see. If I drag it like that, it makes the wrap, it rotates there. Okay, I don't know why it is on there. Let's remove contact set out of this. Let's deactivate this. We try again to rotate. Now you can see there how it's moving. Yeah, it's moving as a unit. It looks nice. Okay, that is it about this one. So I'm going to be testing it a bit there. That's about the contact set. That, yeah. So that's it. So if we try even to, that's how it can actually move in real life. Yeah. So it's something nice. I really like how it's moving and all of those stuff. So yeah, even when we rotate this now around like that, you can see. So when you move away too much, it will leave because it's not making contact with the gear. So if you drag it back, it's going to be making that contact. Looks crispy. Yeah, looks crispy, delicious, yummy. All those words can actually describe. So if I zoom in here, now here's where you can, I want you to observe now in real life. So if we move, yeah, the moment we make contact, the part that is making contact, I want you to observe at this section here. The moment that comes, places there, it makes it very, very accurate. Yeah, and this one like that. So there is some tolerance here, some tolerance there, and then like that. So yeah, that is it for this video. So if you liked what we had, but before even we close, there is something I wanted to talk about grounding. Grounding, most of the time there is a component which you don't want to be moving, so you can always ground it, yeah, without putting the constraints that we have done here. For instance, if I come to place, click place and select this this rack here, click open. If I click at anywhere here, and so now currently you can move it in any direction. So if you right click to select it, then I want you to right click, and then there is this option here, grounded. You select that, it's going to remove all the other degrees of freedom, so it cannot move. And anytime you hover your cursor to that component there, you can see there is that pinned icon there. Yeah, to show that it's grounded. Yeah, it cannot move. You try to move, it's not going to. That's about groundings. All right. Okay, so that is it for this video. So if you liked it, kindly give me a big thumbs up, comment down in this description, also share with your friends. And when you subscribe, it always makes me happy, because it always motivates me to continue making such kinds of educative and informative tutorials, so that you can always be learning from me. Yeah, so that is it. So see you on the next tutorial, where we are going to talk about joints. Thank you. Toodles.